All right, welcome back after lunch. Really good lunch both days here at Force 16 Conference. Up next, we've got the Force 2016 Pitch It Innovation Challenge. We've done it a little bit differently this year, so I thought I would just run through that quickly for you because we've got plenty of entries over here. We have 11 this time that will be given their pitch. I did want to thank our Pitch It Challenge committee, as you'll see the folks there that worked with us on this. And I definitely want to let you know we got the 11 entries. Each entry will have the 5-minute pitch, which will be the course of the next hour that you'll be hearing. We'll have 2 rounds of voting. So the first round, I'll come in, we'll do this with Mentimeter, and we'll do this at the end after everybody's given their pitch. And the first round will determine one winner, and then we'll take that person out of the voting, and we'll do another round of voting, and whoever wins that one will be the second winner. And that's how we'll do the voting for today. And we'll do that at the end after we've done all the pitches. We really wanted to thank JISC for being our sponsor for this year's challenge. That not only did they cover the awards funding, they also worked with us to test out their new JISC elevator software, which is what we use to accept the video entries that you'll be seeing some of today. And this just gives you an idea what it looks like. This is one of the first times they've tried it out with like a conference event. They've done it with some projects at internal universities, and they're about to turn it from a kind of a beta development thing into a real service for their customers there at JISC. And if you met Chris Keene, who's around from JISC, he really helped us get this going for the contest. So with that, we'll move to the lineup here. We've got 11, and we'll move through them. A couple of these I'll have to play the video for them because they entered the contest, but they weren't able to attend the event for one reason or another. And with that, I'm going to go ahead and move into the first one, which is Metric Toolkit.
Hi, so before I do our pitch, I want to tell you who's involved with this project. I'm Heather Coates. I'm the Digital Scholarship and Data Management Librarian from IUPUI. Stacy Conkiel from Altmetric is also involved, and Robin Champeau from OHSU. So those are the folks behind this pitch. So we're here today to call bullshit on the rhetoric surrounding metrics. Metrics do not equal quality or impact. Graduate students, faculty, administrators use metrics without understanding their meaning or value. The abuse of metrics runs rampant, and altmetrics are at risk of becoming just another metric or number that faculty shoehorn into their tenure dossiers, selecting the numbers that make them look the brilliantest. So we need a way that empowers people to call BS on the misuse of metrics. 6 million academics, 11 million graduate students use or are evaluating using metrics in competition for a shrinking pool of funding and jobs. Many kinds of contributions are made invisible by our over-reliance on and the misuse of metrics, and the qualitative contexts of academic and popular attention are often ignored. We all hate it, but what are we going to do about it? So our solution to build a digital stomping ground that points scientists, scholars, academic administrators, and funders to the research-backed metrics that can best support their claims to fame and answer impact questions. Users will be able to navigate the site from 2 directions. The metric selector will match impact questions to appropriate metrics, guiding users to the best tools for their use cases. Oh, that's not showing up right. Here, let's try this. So we have a brief demonstration of what that might look like.
We are here today
Let me
to call
skip ahead.
tools for the
Sorry for the technical
cases.
Challenges.
and will be linked, including metric. And here is a brief demonstration of what our metric selector tool might look like.
That is just a very quick and rough, dirty. Okay, metric toolkit. Where are you? Nope. There we go. So the metric dashboard will allow users to browse different metrics and quickly learn about their scope, strengths, and weaknesses. In both cases, need-to-know and standard information will be linked to the metrics, such as the level, the type, the source, appropriate applications, and misuse warnings. So we have the connections and a plan to reach the convinced, the unconvinced, and the clueless. We'll develop this guide in the open and share the resulting web app and print guide openly, free for reuse and remixing. We've got on-the-ground outreach experts who are on our team who are the best at making one-on-one connections with administrators, faculty, and students, which is crucial to building buy-in. And we've got killer online marketing expertise in Stacy, which will get us grassroots traction in social media, press like the Chronicle for Higher Ed, the Times for Higher Ed in the UK, and hopefully endorsements from organizations like the AAUP and Spark. But most importantly, we've got you, we hope. The Force 11 community to help us get the street cred and word of mouth needed to promote this tool among department heads and other academic tastemakers. So we need this innovation grant to pay for a designer to make the tool as appealing as it is useful. They'll design the print guide of the toolkit and advise us on the web app as well. And as many of you know, that kind of expertise is not cheap, so we want someone who can do a really great job. We've already got promises of matching cash and in-kind donations from all the organizations affiliated with the project, so Altmetric, IUPUI, OHSU. So now we just need your votes to make this happen.
Thanks so much. That was Metric Toolkit. Number 2, we have Mini Reproducibility Project coming to the stage.
All right, good afternoon. I'm James Aiken, and this is Girija Goyal. And we incubated this idea at the end of our graduate program in immunology, and we're very interested in pursuing it further, even though Girija's gone on to a postdoc at Harvard, and I'm in an industry scientist position.
So we are both biomedical, in the biomedical sciences field and bench scientists. And what we really work with is the small data, the wet experiment that biologists do that really forms the basis of preclinical drug development. And this is just a snapshot from Figshare. So if you go to your biological sciences section and look for a figure, which is the traditional way to publish this, there are hundreds and thousands of these experiments being conducted. And some of it does make out, but a lot of it, the way we reproduce data to confirm our hypothesis, to optimize assay, doesn't make it out. And this is what leads to the reproducibility crisis, or it's one of the reasons that it leads to the reproducibility crisis and adds to the $28 billion lost every year. And how it matters to the common man is this is what leads to drugs that don't work or their mechanism of action is not known. And there's collateral damage on scientists' careers. If you can't put out what you worked on for months, if sometimes years, then it has a negative impact on your career. And this is particularly detrimental for researchers in resource-limited settings, where they might be doing rigorous science, they might be doing reproducible science, but they may not be doing the most sensational or novel science. So we wanted to build a tool to showcase reproduced work where submission would take just a few minutes and provide visibility and recognition to junior researchers. We wanted to do this via crowdsourcing and make sure their work not only got formal recognition, but also social media visibility. So what we've built so far is a simple browser extension that allows you to submit, we call it the Mini Reproducibility Helper, allows you to submit any image to our platform. It captures the title of the figure that you're submitting. It will also ask for the DOI of the original data that you're reproducing, including the figure number and any annotations about methodology that you want to put in. I did it this way, at this temperature, this is the time points, whatever. This can be achieved in other ways also. I'm aware that a hypothesis, for instance, would be a good way to crowdsource reproduce data. We hope further to display it in a very visually accessible way where scientists can see all that data, all these small experiments laid out together, and see curated reproducibility index as well as methodologies.
So Girija's shown you the extension and part of our vision for what we came up with. But would scientists actually use it? We realized as we're going along that this is probably the major problem that we would face. So we reached out to our peers, we gave them surveys and asked them lots of questions, and some things came up that were pretty interesting. They definitely wanted the rating and metrics on their productive work that they were putting out there. They wanted to be recognized. They felt that everyone had the capacity to review their peers. And they also felt like if they could get insights into methodology, it could inform their current experiments in real time. Nevertheless, they had some concerns. They wanted to know what their advisor would say. Would this be allowed? They wanted to know if they were out there annotating reproductions, would that allow someone to scoop their story? And they were also concerned about people sort of adding a whole bunch of fake data. So ultimately, our strategy would be to build a community and incentivize interaction with the platform through a user ladder. Right now, we're pursuing two strategies, alliances, and then funding from both philanthropic and government sources.
We do have some time, right? Yeah. I just want, I think there was some other bell that went off.
Okay, sorry.
I just wanted to thank the mentorship that we've had through this. We have a lot of formal, informal mentors. Pretty much every scientist we speak to is a mentor. But last year we went to MozFest for the Open Research Accelerator, and this year I'm a fellow with Force 11. Thank you.
Thank you.
All right, thank you very much. That was the Mini Reproducibility Project. And number 3 is called Open Stories. And I think we're just going to see the video from that. We don't have anybody that's here to do that in real life, so let's go with
Open
this.
Stories would encourage researchers to share their
I'm gonna
success
start it one
stories
more
with
time.
Open access.
Here we go.
Open Stories would encourage researchers to share their success stories with open access, open data, and open education. These open success stories would be mapped and searchable. Want to hear about success stories from a researcher in your state? Click there. Want to know about a success story in a particular country? You can view them. But stories would also be able to be searched by the researcher's field. Learn more about the success stories from biologists, librarians, or historians. There have been other initiatives to collect open success stories, such as the ARCS contest to share stories where open benefits the career success of a researcher, and oastories.org, which collects open access success stories. Open Stories would expand this work by including success stories from open data and open education as well, and by mapping the story. Stories would appear in 3 formats: inviting researchers to record a short video talking about the success, inviting them to share their story in a short, written format, or linking to existing stories, such as ARCS contest entries, oastories.org, blog posts, and talks. These stories exist, but the goal is to bring them together in a format that is visual, beneficial, and can be a resource for advocates and researchers. The main message is that an open, successful academic career is possible. The funding for the Force 11 Innovation Challenge would be used to pay for website costs and promotional swag.
Okay, thanks so much. That was Open
Hi,
Stories.
I'm Chris
submitted
Kropp.
by.
I'm an archivist at
Oh.
the University of Illinois.
Here we go. Let me get out of here. So the last one we just
Also
heard
publications
was,
and
it's
chair
going to
of
keep playing, isn't it?
Publications Board.
Yep. The one we just heard was Open Stories, and that's right, was Open Stories by Aaron McKiernan. And up next, we have the SAA Collaborative Research Series Pitch It Proposal. So come on up and give us the intro.
Thank you, Robert. I'm just going to back this up a little bit here so you can hear that all again. Okay. Great. Think for just a moment about someone whose research you know is making the world a better place. You have someone in mind? Now, think about that person, dead, gone. Okay. Are you thinking about it? Okay. What would you do to preserve and provide access to all of the digital traces that that person left behind? The evidence of their life, the discoveries they made, the influence that they had. That's the practical challenge that I and my fellow archivists face on a daily basis. But it's one to which we believe that many voices must speak. Hi, I'm Chris Prom. I'm an archivist at the University of Illinois and also a publications editor and chair of the Publications Board for the Society of American Archivists, or SAA. I'm here to pitch a pilot collaborative research series, an open access platform to support research by busy professionals. It will test-run technologies that support community conversations around research and practice, or translational research. SAA members aren't necessarily provided research time or support from their employing institutions. Challenges like this affect many members in professional associations. Let's hear about the pilot project that we're pitching today.
Archivists today are responsible for collecting and preserving the full range of born digital formats: email, digital images, complex GIS data sets, proprietary databases, you name it. And the purpose of our research project was to attempt to map the landscape of efforts of archivists and other cultural heritage practitioners that are attempting to provide meaningful access to these born digital collection materials.
We'd like to publish our data and project findings that speak to actionable work done by practitioners and also speak to the desire and challenges of doing research and practice. Our model is iterative and participatory. We want to spark the next wave of research in the archival field and foster a dialogue about the meaning of research and research outcomes.
The archives and library community needs a hybrid publication model that reflects the joint theoretical and practical nature of research. It should foster transparency about the research process, explore emerging issues, and demonstrate how research can fuel progress.
Our work isn't really right for a journal article, a book, or a blog. Research and practice implicates the need for open access, participatory, and experimental publication platforms that allow researchers to balance rigor and timeliness.
Translational research is a great fit for archives, and encouraging research is a strategic priority for our association. SAA would like to help people publish their research while enhancing our existing publications. The model proposed here would do that. We dry run collaborative publishing platforms like Comment Press, Pressbooks, and Hypothesis, issue the pilot publication just described, and assess our project. Over time, we hope to support translational research in other areas of our discipline as well. The archival community needs practice-based research and research-based practice. The collaborative research series and its enabling technologies would broaden participation from our discipline and our association, adding new and important dimensions to the discussion.
I'm excited to get to work with Chris Prom, collaborating with some digital platforms for commenting in the publication's workflow process. This is a project that will be mutually beneficial for the Publishing Without Walls initiative, a Mellon-funded grant project here at Illinois, and hopefully for other professional societies like the SAA.
That's my daughter, by the way. As an archivist, I care deeply about science, I care about politics, I care about culture, I care a lot about the future of the United States, of our world. And I believe that the archival perspective benefits deeply from people in the Force 11 community, in the research communication community, but I also feel that the archival perspective helps tell the story of research in ways that data, citations alone cannot. You see it in correspondence, you see it in other types of documents. And that's the material that we as archivists are charged with preserving. If you feel likewise, please join me in voting yes for the SAA Collaborative Research Series.
Thank you, Chris. And up next, we have number 5, a social information and knowledge sharing. And I'm going to kind of prep the video here. Do we have anyone for that live? No? Okay, great. Then we're going to go ahead and play this one, a social information and knowledge sharing.
Organizations large and small create and distribute information and knowledge to their employees and members. For example, clinicians provide education to their patients before and after an appointment. Emergency responders use highly technical and procedural information before, during, and after an incident. Community engagement organizations translate complex scientific knowledge into simple to understand messages for their population. A large portion of the information is distributed in paper format or electronic PDFs or PowerPoints, and sometimes via web portals and internet sites. However, a great deal of user feedback and user engagement is lost because of these methods of delivering information. Content creators don't know where, how, and if the information provided was consumed, let alone understood and furthermore acted upon. On the other hand, Facebook knows much more about our information consumption patterns, about the information that we care about, and the people we trust the most to receive and consume information from. Amazon and other retailers are capable of targeting highly relevant product recommendations based on our previous user activity. Wouldn't it be nice if we could do the same for critical information and knowledge that we need at every specific moment and place? We at mRendering believe so. However, there are three basic problems that we need to overcome to accomplish this goal. First, content creation tools do not allow the logic and semantic organization and storage of information and knowledge. Unlike inventory control systems for products which allow the categorization and tracking of products across the consumption chain, information and knowledge is not tracked. Second, data formats and transmission methods are stuck in the PC and Web 0.0 eras, still relying on PDFs, PowerPoints, Word documents, and the like. Information packaged in these formats is hard to track, read, and share, especially on mobile. Which leads us to the third and last critical problem to solve. Information consumption mechanisms and users' behavior have changed in the last decade with the advent of mobile technologies. More than 85% of the US population has a mobile phone, and a large proportion of them use it as their primary computing device and only means to access the internet. Our company was founded with the goal to enable education anywhere. We partner with organizations such as the NIH, the International Association of Firefighters, cancer centers, and others to develop and test our technology. We have received several NIH SBIR grants to develop and test our technology. We are looking for support and collaborators to continue to build the next generation information and education platform. Thank you.
All right, thank you. That was
Open data flourishes with education and.
Sorry about that. That was a social information and knowledge sharing. Up next, we have number 6, Radian. Thank you. Yes, let's clap for that one. Up next, we have Radian Data Education and Advocacy. Okay, great. We're in the right spot.
Open data flourishes with education and advocacy, but librarians, and especially data librarians, rarely receive formal instruction training. We instead tend to develop instruction skills by attending workshops and conferences, by reviewing the literature, and by talking with colleagues. In other words, we rely on each other as pedagogical resources. Data librarians come from a variety of backgrounds. With the right collaborations in place, this varied expertise promises to enhance and to energize our profession. But many institutions have only a single data librarian. Consequently, our closest colleagues are dispersed across institutions and throughout the world. In order to better work together, we need a central, collaborative space for curriculum development and community building. Our team proposes a web portal where people who are interested in data education and advocacy can collaboratively develop, share, reuse, and remix openly licensed curriculum materials. Our proposed portal will illuminate the data landscape, opening communication channels between data educators, and encouraging community interaction, knowledge synthesis, and information production. The Radian Data Education and Advocacy community will include Creative Commons licensed curriculum materials like lesson plans, slides, interactive tutorials, labs, and videos that are searchable and browsable. Educator tools to facilitate collaborative curriculum development and interactive online learning. And discussion forums for collaboration, knowledge sharing, and community building. Ultimately, the portal will not only serve to enhance data librarians' pedagogy and advocacy, but it will serve as a broader community space where all those who are interested in open data and data education can convene to help shed light on the world, one dataset at a time.
I'm gonna just give a little talk, hold on. Yeah. So the money from the Innovation Challenge would support web domain and hosting costs. It would support a back-end developer to make the website run really well, and software support, and then as well as outreach and promotion. A project like this needs promotion in order to get people involved and excited about it. And our research team, I'm a data librarian, so I will provide sort of the overall design and vision for the project, and also help with data advocacy and education. I'm involved in communities like these, so without the community involved, this isn't gonna work, so I will contribute that. Ryer Banta also works at Montana State University. He edited the video, did an amazing job, and he's also an expert in instructional design and open educational resources. And Scott Young, another colleague, does front-end development, and he'll also provide expertise in optimizing the site for social media and for search engines, and then also user experience to make sure that it's a pleasure to use the site. So I appreciate your consideration.
And that was the Radian Data Education and Advocacy Portal. Number 7, we have the Real-Time Collaborative Pathway Curation Platform. Come on up. Yes, here we go. You want to just play it?
Networks of cellular processes, often called pathways, drive a cell's response to external stimuli. Malfunctions and changes in these process networks are the driving cause for a wide range of diseases, including cancer. For example, this is a simplified model of transition from a resting state G1 to a replicating phase S in mitotic cell cycle, depicting genes whose functions are often altered in cancer. Creating a system-scale process map can allow us to reason about the disease mechanisms and develop precision medicine solutions. Today, there are more than 600 pathway databases that curate information from the literature. Public data on cellular processes is on the order of hundreds of thousands detailed biochemical reactions and millions of interactions. Yet, we estimate that pathway databases only cover 1–3% of the knowledge in the literature. And due to the rapid increase in our knowledge, this gap widens every day. How can we scale things up? We think that we can make process information representation in a computable formal form a part of scholarly production, but we need good, streamlined, smart tools. Towards that goal, we introduce a web-based graphical biological pathway curation platform based on the community's standard notations for representation and visualization. The platform enables multiple users to work on a shared pathway model simultaneously so that they can make concurrent modifications on the model with built-in conflict resolution and can communicate in a real-time, non-blocking fashion. Here is a demonstration where Alice and Bob collaboratively curate a pathway. They log into the platform, open a workspace, and start working on it concurrently. They can add different types of molecules or compounds, as well as processes that represent the interactions between them, such as biochemical reactions. They can make visual changes by assigning background and border colors, resizing nodes, highlighting or hiding certain parts of the graph. They can also change phosphorylation states of proteins or other features, assign labels, and move nodes. The collaboration is real-time, multi-way, and engaging.
The platform also allows for computer agents that plug into the system and collaborate with humans or each other. Because our system is open and generic, it is applicable to a wide area of cases with multiple agents with different specialties. For example, an NLP agent can find relevant articles as the model is being built, whereas an analysis agent can highlight interesting relations or correlations within a cancer context. Here is our system working with a reasoning agent, Indra, that takes a natural language sentence as input, constructs the pathway, and sends back the result to be visualized. Alice tells Indra through the chat window to build the same EGFR-EGF pathway that we saw in the communication between Alice and Bob. She writes that EGFR binds EGF, and EGFR bound to EGA phosphorylates itself at Y1068. You can see how easily the same pathway is constructed by the help of a computer agent. Our platform takes advantage of the strongest aspects of humans and computers and provides a multimodal communication medium to organize and analyze pathway data. It is applicable to any other domain where we need to build complex models from fragmented knowledge. We believe this is the future of collaborative curation.
Hi, I am Daniela and I am a curator at Wormbase.
Thanks, Chris.
For the Pitch It Innovation Challenge, I want to share with you the micropublic.
So thanks, Chris, for the inspiration, because I'll talk a little bit about that as well. 1/3 of you, unless we do something about it, will die of cancer. Okay, so you are a part of the developed world, most likely, and it is a very, very high chance that your tumor will be sequenced and then maybe profiled in different ways, and then will be sent to a molecular tumor board. That's what happens these days. And that's where the problems will start to happen, because although the molecular tumor boards are trying their best today, they are heavily underpowered. They're very similar to the early discoverers without maps, okay? This is about giving them the maps and try to make them better decisions. And we need this now. And this project is not only about discovering pathways, but it's a very interesting model for multi-way, multimodal communication between humans and computers. So what we propose to do is just bring the system is already built, to major cancer conferences or to major molecular biology conferences, and we'll organize hackathons or curathons using this, and then we will report back next year in the FORCE 2007. Thank you.
And that was the Real-Time Collaborative Pathway Curation Platform. And up next, we have number 8, which is micropublication biology.
Hi, what you'll be seeing is a pitch by my colleague, Daniela Riccitti, on our micropublication project starting at Wormbase. Like other mods, our mandate is to curate data from our community and disseminate it to the public. But of all the billions of NIH dollars spent on model organism research, how much of that data is actually valid but never gets published? So it never gets into our database. These include negative data. We cannot curate data that we cannot see. Our aim with this project is to motivate researchers to submit these data that would otherwise remain unpublished, while also training them to submit their data with a curator mindset, using standards for scientific reporting. I hope you enjoy Daniela's pitch. You want to make it bigger?
Hi, I am Daniela and I am a curator at Wormbase. For the Pitch It Innovation Challenge, I want to share with you the micropublication biology project. Micropublications are not a new concept. Micropublications are minimum publishable units. We are implementing micropublication biology, a platform for researchers to submit minimal research results units according to minimum standards for data reporting. Let me show you a simple practical example. You just tested a new GFP reporter line. You have very interesting results, but for one reason or another, the results get shelved. Data will end up sitting in laboratory notebooks or computer files and will never reach the scientific community. We all know that all publicly funded research should be made available to the community, and perhaps someone else will publish the data after repeating the experiment. and this is a great waste of funds and scientific provenance. I am not there to see your answers, but I'm sure that many of you have done experiments that have never been published and could have been published, and we are all aware that a lot of money is spent every year to fund experiments that will never reach the public audience, including negative data. To overcome this, at Wormbase, we implemented a submission pipeline so that users can submit data for a single experiment. The submission is peer-reviewed. If accepted, it gets a DOI, is published on Wormbase, and metadata are directly integrated in the database. The incentives for the community are that citation can be usable as part of metrics in grants or CVs. Data is discoverable with like data in Wormbase. Scientists do not have to wait for a whole story to have their data published, and provenance is maintained. The incentives for us curators are that we don't have to mine for data because it's directly sent to us. We can enforce controlled vocabularies and ontologies. We can enforce data compliance to minimal standards of scientific reporting, and we can communicate directly to the data producers. We have piloted one submission as a proof of principle. If a lab now has a new GFP reporter line, it can micropublish it on Wormbase in compliance with minimal information standards for gene expression experiment, so the MIS-FISHI guidelines. Users can go to the Wormbase site, click on the link, and have access to a form which is self-intuitive, has autocomplete functions, and have hints embedded to guide users through. Micropublication data is then displayed like other expression data on the Wormbase site and can be cited. Our Pitch It Innovation Challenge proposes to bring the project to the next step and expand to other data types and organisms, and it will also help us to increase discoverability. First, we want to continue a dialogue with BioCaddy Data Discovery Index, and at the same time, we aim at starting a new online journal for future indexing in PubMed. We have a mock-up version of the journal, but the Innovation Challenge support will help us starting a professional site with a backend that will directly feed data into our database. Finally, I would like to mention and thank the other people involved in the project, Paul, Tim, and Karen, who is sitting in the audience with you guys right now. Please go talk to her. We appreciate advices, guidance, and suggestions. I would like also to thank the whole Wormbase group, everyone on the EasyID mailing list, which is a great source of information, and Force 11 for giving me the opportunity of presenting this remotely today. Thank you all for listening.
I'll be around for the rest of the conference in case you have questions. Thank you.
All right, thank you. That was micropublication
Hey, Force
biology.
folks. My name is Erin McKiernan, and
I've done this one more time here. All right, so up next, we have, I lost this too. We have number 9, do open research.
Hello. So I'm John MacArthur, Assistant Director of the Right to Research Coalition, but I'm going to let Erin introduce the project because she's the real driver behind all of this. So let's go like this.
hey, Force folks. My name is Erin McKiernan, and I'm the founder of the Why Open Research Project. Why Open Research is an educational project targeted at researchers to help them learn about the benefits of sharing their work through open access, open data, and other open scholarship practices. We take a very graphical approach to this with a series of cartoons designed to grab people's attention, hopefully make them laugh, and quickly convey key messages. We show researchers how sharing can help them increase their visibility. More eyes able to read and download their work means more citations, media coverage, and potential collaborators. We show researchers how sharing their work can lead to more funding, both by meeting open access and open data mandates, but also by opening doors to new funding opportunities that emphasize and reward sharing. We show researchers how sharing can help them advance their career. Every day, more employers are recognizing open scholarship practices, including them in promotion and tenure guidelines and even in some hiring announcements. We show researchers how open scholarship practices can help authors retain their rights and control how their work is shared and reused. But all of this only gets us so far. We're explaining the why to researchers, but what about the how? Assuming we've convinced them to be more open, what are those next steps and how do they begin to practice open research? Introducing the Do Open Research Project, a sister project of Why Open Research that goes beyond the reasons and explains how to be open. In addition, we aim to connect like-minded researchers worldwide. We will build a website that lays out bite-sized tangible actions that researchers can take, such as sharing a preprint or a conference poster, or even a single figure from their paper with the underlying data. We will pair these action items with step-by-step how-to guides, and pair researchers already doing these things with those who want to learn. In this way, we aim to create a worldwide network of open researchers, open research peer mentors, who can look to each other for guidance and support. As part of the Do Open Research Project, we plan to seed the site with a database of researchers who have already agreed to be peer mentors. We will create an email sign-up form to allow people to join the network and ask them about the open practices they are engaging in or would like to learn. We will implement a badging system both to identify those mentors engaging in a particular practice and to reward those who decide to take action. And we will make all code, content, and data associated with the project fully open. We believe the Do Open Research Project can bring about real change by helping researchers turn their knowledge of open practices into action, and we need your help to get this project off the ground. We're hoping you'll vote for us in the Force Challenge, but also that you'll consider signing up to be a mentor and help other researchers become more open. Feel free to contact us at the following email addresses, and thanks so much for your time.
Great. So Erin's, I think, hopefully this won't play. Grand. Has kind of introduced the project, but I'll just give it a little bit more information. So I think a lot of what we're trying to do here comes out of the idea that for many of us, our interactions with the researchers are brief, during a conference talk, a workshop, or kind of just bumping into them in the hallway. But actually the process of becoming more open as a researcher and things like that is a process which takes years, sometimes maybe even decades. And supporting people across all of that time is really, really important. And we wanted a place where that could happen, where people could take small, simple actions to start off and slowly get increasingly more open and be encouraged to do that, be fed resources, be kind of kept up to date with what's happening in these areas without needing to do all that themselves. So the project will kind of pull together some work that we did at the Right to Research Coalition about assembling peer mentors, a lot of how-to resources and things like that. And really, I think with the Force kind of support, what we'll try and do is pair that with the kind of longer-term engagement piece and start to identify researchers which want to do stuff using kind of forms retrofitted onto resources which already exist, like Why Open Research, which say, hey, yeah, I want to do this, but maybe I can't do it right now. And then what we'll be able to do is start to follow up with them and kind of push them to do it over time. 30 seconds. Any questions? Yeah.
Okay, that was number 9, Do Open Research. And up next, we have number 10, SCAPE, STEM Collaboration and Programming Environment.
Can I turn the sound off?
Yeah, let's do that real quick. And it's going to probably play again while I do this.
All right.
Here we go.
That sounds right.
All right, let's get it back to your full screen.
And then spacebar gets it going.
Yep.
Hi, everybody. Thanks a lot for the opportunity to present here. I'm going to talk about SCAPE, and I'm just going to let my slideshow go so you have some eye candy while I'm talking. At some point, I might pause the slideshow and talk about something. This slideshow is actually built in SCAPE over the last few days. SCAPE's an authoring environment and a group multi-user collaboration environment, and one of the things it can do is you can compose content using Markdown, and then you can then render that content in various ways, including slideshows or PDF, anything really. There's a lot of products in the technical authoring space. I've seen there's some great ones upstairs. Some things have been talked about here at this Innovation Challenge. And SCAPE's in that space of authoring, but it's also in the persistent technical chat space, and it's an unusual hybrid. SCAPE loves is really sort of a glue a place you work in, but it connects with anything that has open standards and open APIs, both connects via input and output. For example, here I'm using MathJax, which is a very standard format, and it, Scape is, you're able to, technical teams are able to talk, or scientists are able to talk using math quite easily. Same with code. I don't demonstrate that here, but I'm a programmer, and I love to talk to my developers and share code fragments and so on. I'll let that keep going. There's really 3 different ways we can look at Scape to sort of separate it from the other things in various classes, like chat systems and authoring systems. Ultimately, Scape is really built for teams. It was built for a team that I worked on, and we used it for years. Teams or technical teams need to be able to use their notation. They need to be able to work globally in different time zones at different times. They shouldn't all have to be online. You should be able to onboard new people and have them learn the institutional knowledge. And ultimately, what you want to do is you want to create ideas, brainstorm, and then refine that and turn that into decision-making, planning, and then eventually a publication or a piece of software that you want to ship. And that's really what it's designed for, is to sort of create a space where all the tools you need, all the integrations you need, both data to make decisions as well as ways to share those decisions with other people. It has tools for that. And then I'm going to we're about to get to a little part where I did do sort of a live demo. Is it going? There we go. No? Okay. So really, the next steps now are the funding. If I were to get the Innovation Challenge funding, that would probably be applied to graphics design and video production, so that then I could use that to solicit more funding either via Kickstarter or other means. And now I believe we're about to see the actual little bit of a demo of Scape. I also exported the same content as a web page. What's that? There, I'm going to pause that. So what we have here is this chat room consists of things called cards, which are, they're like chat messages, but they're quite rich and they're structured and they're really just built with Markdown. And I'm going to just scroll through that. So this whole slideshow you saw, I just blatted out a bunch of text and then told it to export it as a slideshow. What we're about to see now, how much time? 1 minute. Thank you. Right now I'm actually showing one of the Scape's cool features, which is, we use Markdown, but not everybody knows Markdown. And a lot of times you write Markdown and then you have to sort of preview it and see what you screwed up. Scape has this live preview where you can sort of get some nice feedback. It's really great when you are bringing people into your team who don't know Markdown, because they can edit any existing message and sort of figure out what the syntax is. And so it's a good way for teams to sort of catch up on the language. And I believe I'm done. Thank you.
And that was Scape. And I just want to make sure that I get to the next video. So the 11th and last video is entitled Discontinuum Puzzle. And I have a little bit of an intro that the author sent to me to read with it. It's presented by Gopal Tadapalli of Anna University. He says, "It is the coming together of computing and communication technologies that is rapidly changing all facets of institutional activity and social life. The resulting innovations invariably tend to be disruptive. The study proposed in the video facilitates a transformation from potential chaos and/or warlike conditions to a study of evolving complex cyber-physical systems." So let's look at the discontinuum puzzle. And I'm going to have to do this again because we took the sound out.
Works of the following visionary scientists.
Here we go.
The discontinuum puzzle in computing and communications is addressed through the life and works of the following visionary scientists: Joseph Henry, Samuel F.D. Morse, Alexander Graham Bell, James Clerk Maxwell, Benjamin Franklin, Thomas Alva Edison, Max Muller, Andre Dreyfus, Vannevar Bush, Alan M. Turing, Claudia Elwood Shannon, George Boole, Norbert Wiener, Rick Hayes, Winton Cerf, Tim Berners-Lee. The social context and the war times are also explored to comprehend the puzzle. Such a study paves way for the enlightenment of the consumers of these technologies in the areas of computer communications, healthcare, social media, implants, and mobile applications.
All right, that was the discontinuum puzzle, and let's give everybody a hand. Now we're going into the voting stage, and I'm turning that over to Damian Pattinson, my co-chair, who is working on the voting for us here.
Okay, so I hope this works. There were some great pitches. Thank you, everyone, for participating. I thought it was a really great session. Now, luckily for you all, you can vote for two people here. We have two prizes. They're both the same. There isn't one and then a runner-up. They're both equal. The prize is $1,500 seeding money, in addition, funding to come to next year's Force meeting, and also mentorship by a group of experts, including myself and some others. So it's a really great prize. So this will really have a positive effect, I think, on the winner. So please do think carefully. How are we going to do this? Are we going to people up, or are we just going to?
Do we want to? Yeah, we could review again all the ones that we did. Maybe have people stand up as I call out your the name of your project. I'm just going to pull this back up again.
Okay, I'm just getting it up. Yeah, sorry. So it's www.govote.at. Now it'll take a minute for everyone to be able to log in. You should just go to it, and then it'll have and then it'll ask you for a PIN number, which is at the top here, 420495.
And do we want to run back through all the presentations again by title and have people stand up? Is that a good idea? No.
We've only got 5 minutes,
okay.
I think.
All right, so everybody vote.
So I have to remember, you'll have to remember what they were. You can see them here. They should be coming up on your screen, so you should be able to list them out. They're in order that they were presented. Okay, here we go. So votes are coming in. This is very exciting. No, we're just voting once. Sorry. Okay, you're voting for the one that you liked best. We're going to do 2 rounds of voting. Vote for the winner. We will then do another round of voting for the other winner. So just vote for, so you have a choice. You can vote for 2 people, essentially. For those of you who weren't taking notes,
we can also pull back up
the list. No, we can't actually. So the list should be on your screen, so you should be able to see.
Yeah, once you put in the voting.
Just go 2 tabs left. 2 tabs left, you have it open.
2 tabs left.
I think.
Okay, is that helpful? Okay, I'll zoom out. Yeah, okay. Sorry. This is Windows, so I'm panicking.
Let's do it.
What I'm doing. Nice. Great.
So that got everybody in there?
Yeah.
Can you see that, or should I go back one more? There we go. Okay.
Okay. All right, we have 107 votes. I'd say that's fairly representative. So, should we do the winner? I'm going to hit the button, and it should tell us who is the winner of the first award. Are they still coming? Stop. Okay. Here, anyone else? Oh, they're still going up. I'm not putting a time limit on it. Okay, we'll give it. I'll give it till 14. Yeah, but I would say about 150 in this room. So I'd say we've got pretty good. Okay, 2:14, here we go. time to show the winner. The winner of the first round of funding is Radiant Data Education and Advocacy Portal. Well done. Congratulations, that's really good. Just come up. Just come up. Yeah. Congratulations.
I'm so excited.
Congratulations.
Happen. Thank you.
Okay, brilliant. That worked, I think. So what we're going to do now is the same thing. I was going to remove the winner so that it wasn't featured in the next round, but I'm not going to do that because I worried we might lose the data. So I'm just going to press on. This Radiant will still be listed, so please just no one vote for it. It is already won. Is that clear to everyone? It has won a prize. You don't need to vote for it again. So, okay, we'll do a time limit.
Yeah.
All right.
How long do we want for the time? I got a timer here.
We'll do a three-minute voting session because everyone's already got it up now, so it should be much easier. No, so you should move to the next screen. Has it moved along?
Is it working?
Okay, fine.
Okay. All right.
Great.
Starting the timer.
So let's go. How many were there last time? 138. Let's see. We probably don't need 3 minutes, do we? I think.
Now that we've
much
done it one
easier.
time.
Yeah, exactly, everyone. Give it a minute. Oh. Oh, what's happened here? Some people have logged on,
Yeah, I guess so.
finally decided that they... Okay. Is that...
It's been about a minute.
Yeah, I think... Give it another 20 seconds. Right. Yeah. Very good. Okay, here we go. Second round.
Everybody had a chance to vote.
I think we're all there. Let's go. The second winner is Metric Toolkit. Very good. Fantastic.
That's right.
Congratulations.
Thank you.
Congratulations. Well done.
Thanks.
Okay. Thank you, everyone. I think that worked really well. I'm so relieved.
Thanks so much.
Great pitches. Again, thank you to everyone who took part. That was a really great session. Where are we going next? Is it Marianne?